Do we have a question? So general housekeeping thing, if I ding the bell, that is my attempt to get you to focus up here. Once, do not consider that remonstration. If I have to ding it more than once, that is starting to get into the territory where, you know, it is, we'll say, a little bit chastising. All right. So any questions with bell work? We'll also have time a little bit at the end.
These problems right here, we doing these in class, the ones on the bottom sheet?
Those are for you for extra practice.
Okay.
Yeah. For you to do at your discretion. Oftentimes we will do the examples. So today we are going to work through the examples for 1.2. We just didn't have time yesterday. And if you are interested as to the answers, I have posted the lecture from yesterday to Schoology. Fifth period, we did end up we had an extra 10 minutes, so we were able to go over those. So those answers are, the solutions to those are posted. Yep. All right. So today we are going to be starting kind of building up our framework that we're going to be using for really the whole duration of this class. And that is going to be working out kind of the intricacies of what is a function. Before we get into the talking about what is a function, we are first going to start with a slightly more basic idea, and that is going to be what is a relation. Now, I don't quite know about this textbook, but I have seen textbooks that I've used for this course in the past refer to a relation in what I think is, again, a fairly unsatisfactory way, where they might say something along the lines of a relation, here, since I have the notes, that a relation is like a set of ordered pairs. Okay. So if we wanted to think of a relation, this could be like the set of points that is like A comma B and A comma C and maybe D comma F, something like this. And that is definitely a relation. But I think that kind of definition, while fine, technically true, kind of undercuts the point of what we're doing with functions, what we're doing with relations, and doesn't do a great job of highlighting. Is my screen frozen? Awesome. Excellent. Get out. Wanna play nice? Cool. Does not really do a super good job at capturing what is really going on. What is even the point of defining something like this? I think a much better way to think about relations and then ultimately functions is to think about them as a map. We have a bunch of kind of directions, and then this map is going to tell us some kind of end location. Right? Now, think of the directions as kind of all collected. These are going to form what we might call the input space to our map. This would be like telling us to turn right or go straight or do a U-turn, things like that. We're going to put this in a little bubble here. We're thinking of this is the set of our inputs. Does anyone know the word that we generally use to describe the set of all of our possible inputs, all of our possible things? This is like all of our possible x values. What do we call that? What do we say? The domain of our function. Fantastic. So this is going to be our domain. And for the purposes of this kind of nebulous example, we'll say that our domain has a couple of different elements in it. We'll say that it has the element car. We'll say it has the element bird. Maybe it has the element -7 in here as well. I don't know, random stuff just thrown into this giant collection. Okay. Now for a new word. What do we generally say goes along with the domain? We're generally asked to find the domain and the range. Okay, we're going to get to that here in a second. Before we cover the range, though, I want to first talk about its accompanying set. These are like the list of all possible locations that we could end up. These make up what we might describe as the output space. We are going to describe it as the codomain. So think of the domain as being like our inputs and the codomain as being the possible outputs. All right. So maybe it's possible, maybe we're looking at this set and it's possible for our function to end up, or our relation or whatever that is, to end up at one of these 5 values. We've got the collection of all of the kind of instructions. These are our inputs. This is our domain. We have the collection of all the possible locations that we could end up at. This is our codomain. And a relation is simply a way to link pieces of our domain to pieces of our codomain. In other words, it's mapping the, if you turn left, you end up at this location. All right, so maybe for the purpose of this demo, we'll match car to 1. Maybe car will also go to 3. Maybe bird will go to 2. And maybe -7 will go to 5. Just random. And we could, if we wanted to, write that out as a set of ordered pairs. This would be like the ordered pair car 1. This would be like the ordered pair car 3, the ordered pair bird 2, and the ordered pair -7, 5. Right? It's just simply telling us if we follow this instruction, if this is where we are starting, and we do this, then we are going to end up at a particular location, 1, 2, 3, or in this case 5. Now, a couple of things to notice here. Do we notice anything maybe a little bit peculiar about what's going on in the codomain, which is maybe not something that we've necessarily encountered before? Yeah. 4 doesn't get mapped to. Emily, right? Yeah. Awesome. 4 does not get mapped to. And that's okay. Maybe the map that we're currently using can't take us to Europe. It's still a possible location that we could ultimately conceivably end up at, but this particular map just doesn't take us there. It just doesn't have the instructions that can get us to that location. That is totally, totally fine. But I think you're absolutely correct to say that what we have going on here with this 4 is a little bit odd. The fact that the 4 does not get mapped. This here is the difference between what I am calling the output space, the codomain here, and what you guys have been referring to up until this point, which is the range. Right? The range is specifically the locations that you go to. And the codomain is all possible locations that you could end up. Right? So think of it in this case as the codomain 1, 2, 3, 4, and 5. The range is only going to be 1, 2, 3, and 5. This 4 never shows up. It doesn't get mapped to. Doesn't mean our map is bad. Doesn't mean there's anything wrong with 4. It just didn't happen. Didn't happen in this particular instance. And so we say that maybe the range here, we say that these are the actual outputs. So if I describe the codomain as the possible outputs, the range is the ones that, these are the ones that we actually see. This feels like maybe a little bit of a weird distinction. We are actually going to see this come up several times throughout this course, specifically when we work with inverse functions. But just to kind of give you an idea of why we might care about something like this, let's say we were trying to come up with describing what's happening with the function like y is equal to the square root of x. We have the y-axis here, which is all of the positives and negatives going up and down. We have the x-axis, which obviously also all the positives and negatives going left and right. And what's interesting here is that the square root of x is always going to be positive. So even though there's like a region for our graph where it could be negative, it's just not going to be. It's just never going to be. It's always going to be kind of stuck in this positive space. And so even though that space, those negative numbers exist, we don't use them. That would be the difference between the range, which is all the positive numbers, and the codomain, which is maybe just all the real. Yeah, the codomain can it's basically just anything that lives in the set. And the range is anything that lives in the set and also gets hit by the mapping. So notice here, 4 is part of the codomain because it lives in the set, but it's not part of the mapping, so it's not part of the range. Yeah. It's not something that's like super important. Again, that's really more just to kind of scaffold this idea that we will need later when we are working with inverse functions. So hold that thought for like a week and a half, and then it'll come up again. All right. So questions here so far with any of our definitions. What is a relation, domains, ranges? A little bit less worried about codomains. Those three. The big header, generally we don't work with relations very much. We absolutely could think about relations that are like this. They're kind of arbitrary and not particularly interesting to think about. We instead like to look at a subset of relations. So kind of similar to how all squares are rectangles, but not all rectangles are squares. We like to look at functions, which are a specific type of relation. So what about a function makes it kind of a special kind of relation? Maybe a little bit more specifically, why would this mapping that I have drawn here not be a function? What is the problem that we have here? So actually we can have a function that is just like random names or letters going to something else. It's a little bit weird. Generally we will work with numbers, but that is not necessarily the problem. So which point is the problem child? So the fact that car is getting sent 2 different places is a real problem for us. If we want to think about this like a map, right? We think of these are the instructions that we follow, these are the locations that we end up. This is like telling you that if you turn left, you will either end up at Albuquerque or Tupelo. It's not a very useful map if there is that kind of ambiguity. There's ever a question of, am I ending up at point A or point B after following these instructions? It's not well defined. It's not a good, in this case, map. And so we want to think of functions as the technical term would in fact be well defined, but we want to think of this as a relation where none of the inputs get repeated. Or another way to say that, with no repeating x values. All right. It's okay for now, anyway, to have repeating y values. Right? It's okay if we turn left and end up at Albuquerque and turn right and end up at Albuquerque. That's totally fine. Right? That map is doing its job. Just because it's not a particularly interesting map where the decisions that you make don't really matter. Just because it's not a very interesting map doesn't mean it's a bad map. A bad map is one where you are just tossing a coin at where you might end up. Are you ending up at one, the other, both? Who even knows? Right, so functions are these good maps. Good maps mean none of this overlap in instruction to output. All right, so let's take a look at a couple of examples here. The goal here just to identify whether what we are looking at is a function or is a relation. For example A, I'm actually going to add an extra caveat here. We're going to say that the grade, that the percentage grade is the domain. And we're going to say that the grade point average is the range. This could be range or codomain. In this case, they're the same. All right, so the question here is what we are looking at a function or a relation? And this one is a little bit tricky with how it is presented. So what I kind of like to do here is just give you a very quick idea of what we're talking about. Let's try to evaluate what this function would be at a particular point. The way it's blocked is a little bit weird, but let's maybe think about what would happen if we got a grade of a 65. Do we know definitively what the corresponding GPA would be if our grade is a 65? What is it going to be?
1.5.
In this case, 1.5. Okay. What if we get a grade instead of a 63? Also 1.5. Was there ever any question of what that output was going to be? No. So it's okay that they share outputs. Right? That's totally fine. There can be an infinite number of these values that give us 1.5, but the fact that we know if I get this grade, I'm guaranteed 100% of the time going to see this 1.5, that is what makes this a function. So if the domain is the grade point average and the range is, if the domain is the percent grade and the range is the grade point average, then this would be a function. Okay. Let's try flipping this around though. Let's maybe consider what would be going on if our range were the percent grade and our domain was the GPA. Now, when we try to do this, if we take our new function and ask ourselves what is g of, we'll say 1.5, can I, from that, definitively tell you what the corresponding grade was? No, definitely not, right? Is it 65? Is it 63? No idea which one it's going to be. And so to that end, this is not a function. Right? It's that ambiguity that we hate. Right? We don't like not being able to get a definitive answer. So here it's okay that we have a lot of overlap. The only thing that we are struggling with is if I'm looking at an individual point and I don't know exactly where it ends. All right. What about with B? What's going on with? Is this going to be a function? And if it is not, then what is the problem child? What is the point that is causing us concern? Yes. Q, absolutely. The fact that Q is getting sent both to Y and also to Z is a problem. So in this case, because Q is getting mapped to two different places, we don't know where we're going to end up. This would not be a function. Okay. And what about for C? We've got plus or minus the square root of 1 minus x. This one. Yeah, because of the plus or minus. If we plug in something like 0, we'd get like plus or minus 1. It's either positive 1 or negative 1. The fact that there's an or in my answer means that this is not a function. Absolutely. Fantastic. Yes. Okay, so that is a very, very good observation. If we were to talk about the domain and range, and the size of the domain and the range, then we could make the observation that Tyler is making, which is that the domain is smaller than the range. And if the range is everything that gets matched to, that means that there are pieces of the domain that have to get used more than once. So a very good gut check would be just the fact that the domain here is smaller than the range means that this can't be a function. There's no way that this could be a function. Now, it doesn't swing the other way, right? The domain can be bigger than the range and still not be a function. The domain can be the same size as the range and still not be a function, but that observation that in this case, because this is smaller, it has to get mapped to two different is a really good one, and that is absolutely true. Yeah. It still would not be a function because Q is still being sent to two different.
Oh, so how did that work on the first one?
That one wasn't a function. That one was just a relation. Not
Oh, not
yeah, that one was not.
Okay.
Yeah. Yes.
If two different domains went to the same range, would it be a function?
So two different
Domains.
so like elements in the domain. So like in that case, like the Q going to the Y and to the Z.
Yeah.
Then that is not a function.
Wait, but if it was like opposite.
So if you had like Q going to Y and then also what's the other one? P going to Y as well.
Yeah.
Then that would be okay. That would be function. Because if you look at, like, let's say that in this case P goes to X and also Q goes to X. That's okay, right? Because you know where you're going to be when you follow the instruction. If you follow P, you end up at X. If you follow Q, you end up at X. We know where we're going to be. It's a little boring, but you know, such as something. Good question. And one of the things that people do generally kind of mix up is what happens when we got like one arrow coming here, one arrow coming here. Very similar to what we looked at with the table, right? Where a grade of 65 and a grade of 63 net you the same GPA, but the fact that we can tell you definitively this is going to be your GPA means that it is a function. Yeah, good questions.
So that was just, if C was just, if it didn't have the plus or minus, it would have been a function.
Yes, that is true as well. Yeah, if it didn't have the plus or minus, then it would have been a function as well. Very good. All right. Cool. Now, alongside this, and I already have used this, so I do kind of, to some degree, have the expectation that this is something that you guys have seen before, but I do want to go over it, and that is the function notation that I have used here. If I were to, for instance, write that f of x was equal to we'll say like x squared plus 7, and I want to know what is going on at f of 1. This is f of 1, not f times 1. What am I being asked to do? What am I asking you to do by asking you to evaluate f of 1? Yes. Absolutely, fantastic, Brian. So we are taking all of the x's here, and just like over here, what have we done to go from here to here? We've taken the x's and replaced them with 1s. We're doing the exact same thing. Everywhere we see an x over here, it just gets replaced with a 1. I recommend when doing this to just use parentheses. It's helpful for when you're plugging into a calculator. If you have to plug in a negative value, you want those parentheses to make sure you're not like squaring something and then making it negative. But yeah, the basic idea here just being that you are replacing everywhere you see an x with 1. So looking at this next page here, looking at example 2, we are trying to evaluate these given functions at the specified values. I am going to go through the 3 here for A, and then I'm going to give you guys about 5 minutes to work through B and C here. All right. So in this case, we are told that f of x is, in this case, 3 to the power of x. We are asked to find what is f of 0. So what am I being asked to do? Everywhere I see an x, I'm going to replace it with a 0. So in this case, this is 3 to the power of 0. Just a quick kind of rule of thumb for this class. For the most part, and I will tell you when this is not the case, I do not require you to simplify. So this is the benefit of, congratulations, you've reached a senior level math class. If you were to continue going on, you would continue to not have to simplify. You could write this as 1 if you wanted to, and that would be correct. You can also leave it as 3 to the power of 0, and that's fine. Okay. F of negative x. What am I being asked to do? Everywhere I see an x, replace it with a negative x. This is going to be 3 to the negative x. Again, you could write this as 1 over 3 to the x, but I'm also fine with this. This is totally fine. And then lastly, we're looking at f of x plus h. What am I being asked to do? Everywhere I see an x, I am replacing it with this x plus h. This is very simply 3 to the x plus h. All right, so take a moment and try out B and C. Again, keep in mind that what we are doing is we are replacing the x's with what we are, in this case, being asked to do. Taking a stab at B and C, for example, 2. That's a great question. So if there's nothing to replace, then
Yeah, right.
Awesome, yeah. Great.
What is 0 squared?
Awesome.
0.
Fantastic. Fantastic.
17.
Now you are, it does want you to do it for all of them. So that's kind of what I did up there. But yeah, this is, and you don't have to. But you can simplify if you want to. I will not. I will certainly not. This was. Yeah. Now when we're putting in 0, 3 times. But otherwise, that's great. Yeah, that's great. Yeah, that's yeah. Yeah, it's because something's raised to 0 is. Remember 3 times. So this would become 0 squared is 0, but 2 to the power of 0 is 1. Yeah, so 0 squared is yeah. That looks good. Fantastic. Awesome. Hey, how are you feeling about? Yeah, so when we go to substitute in for x, then we
Wait, no, it's not.
no, because there's nothing to be substituted. So it'll just kind of stay. That's why it's the constant function, so it's just always going to be. All right, awesome. These look really, really, really good. In my other class, we had a couple of questions about B. I intentionally tried to make B a little bit tricky, which is just very simply, there isn't an X to substitute. And a lot of people try to make it a lot harder than it is. And it really is just, if there's nothing to substitute, then it just stays the same. Right? There are no X's to replace. And so for all of these, they're all just going to stay 12 because it doesn't do anything. There is no X. Right? And then what I saw for C was really good. Remember that when you are plugging in 0, 0 squared is 0, but 2 to the power of 0 would be. So when you raise 0 to a power, it is 0. So in this case, f of 0 was equal to -6. F of -x, remembering to plug in with those parentheses. If you were to simplify it, this would look like 3x squared minus 7x minus 6, and then f of x plus h here was just taking everything that you see as an x and replacing it. Yes. So it would be 3x squared because the negative x, when you square negative x, it's going to become positive x squared. Yeah, good question. Yeah, good question, right? And I'm fine if you leave that entirely unsimplified. You do not need to do that. All right. So we are going to have the bells should be back and working. Do they generally go off for lunch? They do, right? Yeah, so we should have the bell going off here in just a second. All right, and we will wrap this up when you guys get back. Have a good lunch.
Yeah, please tell him that.
I would like to. Cool. All right. One more thing that I would like to cover. I'm going to give you guys the rest of this time to work on the 1-2 classwork. Give you guys a chance to get a head start on that. So the final thing that we are going to be looking at, I guess technically not the final, there's one more topic that we'll kind of wrap up. Tomorrow, the final thing that we're going to be looking at today with regards to differentiating between whether we are looking at a function or just a relation is with what we are going to call the vertical line test. And the logic here is fairly straightforward. If we are looking at a graph where the x-axis represents our inputs and the y-axis represents our outputs, then in order for that graph to represent a function, then there should never be more than one y value for any given x value. In other words, if we look at an x value and we see that there are two heights that correspond to that particular x value, then it cannot be a function. Right? And this is it only needs a single kind of point at which that is true. So for instance, looking at example 3C here, can we identify a point where there is a single x value that is being mapped to two different y values? Okay, so 0 is a good idea. The only problem with 0 in this case is if you look really closely, it's got that open dot. What that open dot means is you want to include everything that's really, really, really close to 0 without actually including 0 itself. So this upper line actually does not have, when x equals 0, it's not referring to this upper line, it's exclusively referring to this lower line. Yeah, that dot is open. So is there an x value, looking at example 3C, where we see one x value kind of being used for multiple y values? Yes, Emily.
1.
Yeah, at 1 I think is a really good example here. And notice that if we were to draw a vertical line straight down from x equals 1, that we would intersect our graph at two different locations, more than one. So this is why it's called the vertical line test. If you draw a vertical line straight down at any point on your graph and you ever hit more than just a single point, then it is not a function. So in this case, this is telling us by the vertical line test that this would not be a function. So if it intersects at 2 points or more, then it's not going to be a function. If you can draw a vertical line through every single x value, and it only ever hits 1 or 0 sometimes, but it only ever hits 1, then what you're looking at is a function. So actually, in this case, the converse is true. Looking at A here, this one's a little bit tricky. If I were to give you something on like a quiz or a test, I make it very clear whether it passes or fails the vertical line test. What is potentially the problem child here for whether this is a function or not?
The 3 points in the middle.
Yeah, maybe with like right at what's going on around 0. If this ever were to go completely vertical at any point, then it would fail the vertical line test. I will go ahead and give you that it does not go completely vertical. Notice that there's a little bit of spacing, there's a little bit of a slant to those 3 points. And so is there any value of x where we have to worry about hitting more than one point on our graph? No. And so would this be a function? Yes, this is a function.
So this is like the same thing as if like on the chart there's more than one y, x value.
Exactly.
So
Exactly, yeah. If you were to look at the graph, the way you would see more than one x value is this like 2 points lined up on top of each other, basically. Yeah, very good question. Yeah, just basically different representations, and here we've named the check for it. But really, you're just looking at, are there ever 2 points that are like above each other on this? In this case, the answer would be no. Again, picking examples that are a little bit annoying, also don't print very well. Looking at B, where would we maybe want to be a little bit worried here? Maybe also 0, maybe what's going on at the y-axis. If this side ever did intersect the y-axis, if those sides ever did touch the y-axis, then we would certainly want to be worried. In this case, this red dotted line is telling us that they actually never reach the y-axis. This would be a vertical asymptote. So if we were to run a vertical line right here, it just never touches. It wouldn't hit any points in our function. And so this would also pass the vertical line test. And again, the ones that I would give you on like an assessment are going to be a lot more clear as to whether they pass or fail. These are just like a couple of somewhat tricky ones where it's obvious for the most part, except maybe one. All right, any questions with what we have looked at with 1.2? Anything that we have done today that we would like to address? How are we feeling?
Can you explain the domain and range thing one more time?
Yeah, absolutely. So think of the domain as kind of the collection of your possible inputs. So the things that you could possibly be plugging into this map. I think of the range as being your possible, the outputs that you can see. Most of the time, and we're going to look at this a little bit more in, I believe 1.3, although let me, before I say that, let me actually double check. Some of the trickier problems that we end up doing do relate to identifying domains and ranges. I forget if this is in the 1.2 or 1.3. Determine, give the domain range. That one's fairly straightforward. Yeah, I think it'll be maybe the 1.3. Yeah, but the TLDR here is we're going to get a lot of practice with determining what the domain is for particular functions. Actually, yeah, that's something that we're going to cover at the start of class tomorrow, is like looking at different functions and trying to kind of identify what is the domain, when do we need to worry about that. For the most part, we are going to be looking at functions, a little bit of an asterisk, that take a real number and spit out some other kind of real number.
Okay.
Yeah. So the domain is predominantly going to be all real numbers, except in some special cases. And the range will more depend on the function. Sometimes we have functions that are always going to be positive. Sometimes we have functions that are going to be trapped and oscillating between 1 and -1. It's just going to depend. Laptops? Yes, absolutely. Great question. And that is one that people will get a lot of practice with that, because people do generally find that to be a little bit tricky.
Thank you.
Absolutely. Any other questions? If you didn't get it today, I know it's going to be sometime at the start of next week. I don't know the exact timeline. Yes.
For like number C,
Yeah.
with like the F and then the X plus 8.
Yeah.
Is there something about
Yeah.
Do we just leave it?
So if it was like a multiple choice test, I could give you the simplified version, and you might have to simplify it to that simplified version. But if it's like a fill in the blank of what is f of x plus h, then you can just leave it like that, and that's correct.
Okay.
Yeah. With the except, there's going to be one type of problem that we're going to look at when we do rate of change, where I am going to want you to simplify. It is also unfortunate because it is the most annoying kind of simplification that is fairly difficult. The payoff is that when we are working with fractions that have no numbers in them, it's going to have kind of prepped us for some of the algebra that'll go into that, so we're not making some mistakes that we often see with that. But for the most part, for things like this, I am totally fine if this is like a fill in the blank. You can box this answer. This is great. Oh, well, you can't see it, but that's great. Right there. Perfect. Any other questions? Yeah, absolutely. And in fact, to that point, since the bell work was complete, the classwork that is due at the end of the class today, you guys are free to take a picture, turn that in. That'll get you that one kind of extra credit point for this assignment. And then you'll resubmit it for the 1.2, resubmit it for the 1.3, if you want those kind of extra credit points. Yeah.
So we just always submit the classwork, like each picture.
If you don't have it finished and you do it all at once, then you can submit it all at once in one document. But if you want to do those like incremental checks for bonus points, then I would just do it like that.
Thank you.
Yeah, absolutely. Yes.
How do you want us to submit it?
Just take a picture and then upload it to Swilly. Yeah. You can take it with your computer. Yeah, photo booth with your computer. Yes. It is in the works, I have been told.
And then I tried to pay the fee,
Yeah.
but I couldn't find, like it has a list of the classes and the fees that you're supposed to pay for them. And it didn't have like a map here.
It's not under like me specifically, it should just be a generic fee, but I can look into that.
So we're doing 1.2.
Yeah, so what I would say, so what I am going to, what you would turn in at the end of class on Monday, for now, we'll just keep it the end of class for this first assignment. End of class on Monday is going to be the 1.2 problems. There are a fair number of them, but a lot of them are like, use the vertical line test to identify if this is a function. Look at these ordered pairs and say whether or not it's a function, things like that.
We do that all 100.
No, do not do all 140 of those questions. Instead, what you're going to want to do is on Schoology, if you go to the 00 through 13 problem set, classwork set, and you click on this document right here, this has a breakdown of the problems that I want you to do. Yeah. Yes. Yeah. No, that's just 27.
Okay.
Yeah.